So, hello everyone, welcome to another video in which I'm going to discuss something about the queuing theory. Okay, so this is again one of the important subjects in management and especially in operations management, where you are offering services and there are queues and you want to reduce the waiting time in the queue, reduce the processing time, and so on. So, because the customer wants to serve, get service in a very fast way, and you don't want the customer to wait a lot. Okay. So, anyway, so let us now see what this is. So, to explain this, uh, I'll just go through the question and then I'll just show you the formulas. Okay. So actually there is a lot of mathematics behind it because this goes into Poisson's distribution and probability theory and so on. So we'll simply see. I'll just show you the formula sheet. So we'll simply see a single server analysis. That means there is let me draw the picture here. So there is a queue. So and there is a customer, another customer, another customer, another customer, so on. Okay. So these customers are arriving at a certain number of customers per hour or number of customers per minute, something like that, called arrival rate. Arrival rate. So this arrival rate is usually uh, determined by lambda. Okay. So that is a symbol used. Arrival rate. Okay. So number of customers per minute. So let me just confirm that. So there are two variables, arrival rate and what you call processing. That is, yeah. So lambda is number of average number of arrivals per time period. Okay. So now there is this processing, right? So some counter is there, and the great one attendant is there, attender, who attends to these people, maybe billing counter, whatever. So this particular person takes a certain time, so that is called processing time. Okay, so our rate of server. Okay, so we call it mu, that is number of service customers served per hour, okay, or per minute or per whatever the time. Okay. Now what happens if the arrival rate is more than the mu? If lambda is more than mu, what happens? Every hour more customers are arriving than every hour how many customers are being served. So therefore, as a result, if lambda is mu, the queue keeps on increasing. So any design of the system should be such a way that your arrival rate, average arrival rate, should be less than the person who is at the counter, the processing rate. So lambda and mu. So basically the main two parameters are lambda, mu. And one more parameter is, and this lambda should be one more parameter is S. That is the number of counters or number of attendants or number of servers, whatever. Okay. So these three things are there. Then these formulas. Okay. So probability of number of customers. That is probability of zero customers is 1 by that is no customers, 1 by lambda mu. Probability of n number of customers. So this is a formula, lambda by n to the power of n minus 2. So these all derivations come from probability theory. So right now we don't worry about that since we are doing management. We'll just simply learn the formulas. Average number of customers in the system is lambda by mu minus lambda. Average number of customers in waiting. That is uh, at any point of time, how many average number of customers are waiting. That is length of your queue basically. So lambda square minus. What is the difference between system and waiting? System means it is counts both waiting people and the people who are being processed, people who are being serviced. Okay. Average time per customer, both waiting time plus service time, is this one, W. Average time per customer, only the waiting time, is WQ. So this is number of in the waiting, like that. And probability of server being busy is lambda by mu, and probability of server being idle will be 1 minus lambda by mu. Anyway, these are the formulas. If you know these formulas, it's very easy to calculate. Okay, so let us solve this problem. So the problem is like this: a gas station. So you can pause the video now, and you can look at the formulas, and you can try to solve the problem. So the formulas are like this. You can pause the video and note down the formulas, and again you can pause the video now and look at the problem and you can solve it. Okay. So anyway, let me now solve it. Okay. So eighth question, gas station. So what do I have at the gas station? What is the first statement given here? So the attendant checks tire pressure, whatever, what we don't care. On an average, the attendant takes 2 minutes to check out one car. Okay, 2 minutes in one car. That means for 30 cars, 30 into 2 will be 60 minutes. That means uh, number of cars served in 1 hour. Okay, so let us call this mu. Okay, so this is 30 cars per hour. Why I am saying mu? Because for 2 minutes for one. Okay, so 2 minutes for one car. So therefore, for 30 cars, it will be 60 minutes. 60 minutes means 1 hour. Therefore, mu is 30. Now, what is the other one? Cars arrive at the service rate of 17 per hour. Okay, so lambda is 17 cars per hour. Then they're talking about only a single attendant. Okay, so S equal to 1, single attendant. Determine the number of cars that wait in the queue. Okay, so number of cars that wait in the queue means number of customers waiting in the LQ. Okay, so what is A is LQ, that is nothing but lambda square by mu into mu minus lambda, that is nothing but 17 square by 30 into 30 minus 17. So that is nothing but 17 square. So 17 into 17 divided by 30 divided by 30 minus 17 is 13. Okay, so again 13. So I'm getting 0.741 cars. Okay. So what it says is number of cars waiting in the queue is 0.741 at any point. That means less than one car is in the queue. Okay. So that is good. Okay. So we can round off to one car. So at all the time one car is serviced and one car is waiting in the queue. Something like that. Now let's look at B. Okay. So what is B? Determine the number of minutes cars wait in queue. Okay. So that means WQ. So what is the formula? So here you can see average time per customer waiting only. Service we are not adding. So lambda by mu into mu minus lambda. So same thing, just that lambda is not there. So lambda by mu into mu minus lambda. So which is 17 by 30 into 30 minus 17. Okay, so that is equal to. So let's see. 17 divided by 30 divided by 13. So 0.0435 whatever 36 whatever. Now this is in hours. So now convert into minutes. So multiply by 60. So I'm getting 2.615 minutes. Okay. So 2.615 minutes, or how can I can round it off to 2.62 minutes. Okay. So this is the waiting time per car. Okay. This is a car has to wait in the line 2.62 minutes. Then car will be serviced by 2 minutes. Then total car time will be 4.62. Anyway, that will be the next question maybe. C. Determine the duration car stay at the gas station. Okay. So the C part, car stay at the gas station means that you have to say average time per customer is W. Okay. So W is nothing but 1 by mu minus lambda, that is 1 by 30 minus 17, that is nothing but 1 divided by 13. So 0.07692 whatever. This is in hours. So again multiply by 60 to get the time in minutes. So that is nothing but 4.62 minutes, like this. Next, what is the next question? So if I go back here, what percentage of time is the attendant busy? Okay, so what percentage of time attendant is busy? So here you can see probability of server busy lambda by mu. Okay, so simply D part U is equal to lambda by mu. That is nothing but 17 by 30. That is nothing but, so 17 divided by 30. 0.566. You can round off to 56667. Now this is in the form of fraction. Now the question is percentage. So percentage is nothing but 56.667 percentage, or you can round off to 57 percentage of time the server is busy, or server is busy. So we solved the eighth question, part A, part B, part C, and part D. Now let us go to part E. Okay. So the manager of the station is considering adding another attendant only if it will reduce the waiting time by more than 50%. What do you recommend? Okay, so now these formulas are true only if it is a single server. What if there is a multiple server? There are formulas available, but they are too complicated. Too much mathematics is there in that, with summations and factorials and things like that. So we will not learn that formulas. We'll simply use the software. Okay, so for solving E, use QM for Windows software. So I will explain how to use this QM for Windows. Okay, so just go to you have to install that software. So you can search online QM for Windows. So I already have that software. I have installed it, QM for Windows. I'm opening a empty software like this. And the most important point, listen to here carefully, which one you should select. Okay, so on the left side, there are different modules. Here, go to the last one, waiting lines is there. Okay, it may be very small in your screen, but you see waiting line. In that M by M by S. Okay, so that one. Okay, so let me write down here. So waiting lines, capital M by small s. Okay, so this is the code. You select like this, then you will get one screen like this. So simply give a title. So I'll just simply say gas station, and then simply go for OK. So the this thing opens like this. Only three parameters are required: arrival rate, uh, and the process rate, that is lambda mu, service rate, that is. So lambda, in this case lambda is 17, and service rate is 30, and let's take only one server for to begin with. Okay, the moment I press enter, you will get the solutions. Okay, you see, so I'm getting the solutions like this. Okay, so now we can edit the data, or we can look at the solutions. Okay, so now what you can see here, uh, what was our first solution? 0.741 cars. Okay, so now here you see 0.74. Okay, so this is the solution. Average number of customers in the queue, 0.74. So this is correct. Okay, so let me just put that, confirm. This one is correct. Next one, WQ. So that is waiting in the queue. Okay, so 2.62 minutes. So here you can see uh, average time in the queue, 2.62 minutes we are getting. So therefore, this answer is also correct. Next one is total waiting time in the system, 4.62 minutes. Okay, so again you see 4.62 minutes is there in the solver also. Okay, so it is no need to do all these calculations here. Simply open the software, enter this number 1731. That's it. Press enter, and you will get all these answers. Okay, so no need to do all this if you have that QM software. Now U is the server is busy. Percentage of time server is busy. So again here you can see the first one, average server utilization 0.57. So that is also matching. So our answer is correct. Now the question is, should we go for the second attendant or not? Okay, so what is the condition? I go to the question. What is the condition? The manager of the station considering adding another attendant only if it will reduce the waiting time by more than 50%. What do you recommend? Okay, so now I'll make a small table. Okay, so here, let me write the answer here for this one. So number of attendants and waiting time. So we have one attendant. What is the waiting time? Here you can see the waiting time in the queue is 2.62, whereas the waiting time in the system we should not count. So 2.62 only I will be taking. So 2.62 minutes. Now if there are two attendants, how much will be the waiting time? Okay, so let us solve for this. Okay, simply go back, and here we have to say edit data, and then the other two remain same. Here enter 2 and press enter, and that's it. Just like magic, you get the solutions. Okay. Now what is the waiting time, average time in the queue? So it is 0.17 minutes or only 10 seconds, 10 and a half seconds. Okay, that's it. Okay, so here uh, 0.17 minutes. Okay, so that is the answer here. Now what is the condition? If the waiting time reduces by 50%, then I can go for second attendant. But not only 50%, it is much less than, So waiting time is reducing by more than 50%. So 50% means 1.31. Okay, so it is much more reduced, right? So therefore, definitely go for second attendant. So that is the answer for this question D. Okay, so what do you recommend? We recommend to go for second attendant. Okay, so like this, we completed the analysis of the question number 8. Okay. Now let us quickly look at the question number 9. Okay, so you can just pause your screen and look at the question, and you can try yourself with this thing. Otherwise, you can just follow me how I will be solving it. Okay, so now let's see. A small grocery market has one checkout counter. Okay. The counter clerk takes average of 3 minutes to serve a customer. That means per customer 3 minutes. So in 60 minutes, 60 divided by 3, 20 customers. Okay. So now let me write that. So so this is the ninth question. Small grocery. So that is service rate. So service is nothing but 3 minute per customer. So simply service rate will be 60 divided by 3, that is 20 customers per hour. Yes. So what is the service rate? We are calling service rate as mu. I always get confused. What is service rate? Yes, service rate is mu, that is 20. Okay. So this is customers per hour. Next, what we have here, customer arrive at the counter at the rate of 15 per hour. Okay, so lambda is 15 customers per hour. So again, we already know if lambda is more than mu, then the queue keeps on increasing and there won't be any reduction in the queue, and it is bad for business. But anyway, this is correct. Next, the manager of the store receives feedback from customers that the waiting time is long and store needs another checkout counter. The manager plans to open another checkout counter and divide the arriving customers equally, all these things. Before implementing decision, he want to evaluate the cost benefit analysis. The manager estimates that opening another checkout counter would cost him 70. Okay, so let me write down here, cost of second counter is 70,000 rupees per year. Okay. Now, the manager also estimates that reduction in waiting time by minute earns the revenue of 10,000 annually. Okay, so if waiting time reduces by 1 minute, then revenue increases by 10,000 per year. So now let us see. See, if 7 minutes waiting time is reduced, that means I am break even. Now, if 8 minutes waiting time is reduced, then definitely my revenue will be more and my justifies to go for the second counter. So let's see what is the question. The manager also says, recommend whether or not the manager should open the second counter. So it is very simple. We make a similar table like this. Okay, so number of counters, number of counters. So we have one counter, then we have waiting time, waiting time per customer. Okay. So number of counters is 2. So I just want to know what is the waiting time. Okay, so since I'm lazy, see, I can apply this formula and do, but anyway, for the case of two counters, I need to use QM. So I'll directly go to QM. So remember, lambda is 15, mu is 20. Okay, so go to QM software. So I'll save the old this thing. Okay, so let me save it, gas QM. So now one more new file I'll open. So this one I will say grocery, Grocery. So here lambda, that is arrival, that is 15, and service rate is 20, and number of servers is 1. Enter and the answers will come. So here you can see we have average time in queue, WQ, is 0.15 hours or 9 minutes. Okay, so I can see, I don't care about other answers. Here the customer waiting time is 9 minutes. So this is from QM software. Okay, so these are the results from QM software. Okay, 9 minutes. Now when there are two counters, what happens? Okay, so I go back, edit data, and then type here 2. So I got the solution. So the minutes is 0.49 or zero point 0.5 minutes, you can round off to. So 0.5 minutes are 30 seconds. Okay, so 0.5 minutes are equal to 30 seconds. So how much is the reduction? So reduction in, so 0.5 minutes I have written here, sorry. So reduction in waiting time per customer is 9 minus zero point 0.5, so 8.5 minutes. Therefore, increase in revenue will be 8.5 minutes into 10,000 rupees per minute. Okay, time is money, people say. So that's it. So minutes will get cancelled, and here I'll get 85,000 is the increase in revenue. So increase in revenue is 85,000, and cost of counter, this is 80,000 per year, and cost of counter is 70,000 rupees per year. So therefore, the decision is, this is given data. So therefore, the decision is go for the second counter and increase your revenue of the grocery. So I think this is the answer for your question number 9, and I hope you found this video useful. We solved two questions. This is the first question, and this is the second question. And for both, main important thing what I wanted to show was this formula sheet. But this formula sheet applies only for a single server case. And if you have multiple servers, like adding extra attendant, adding extra counter, whatever, then you have to use QM software, because the formulas are too big to be doing hand calculations or Excel calculations. So I think you found this useful. So thanks for seeing this video. So if you like it, press like button, and see you in more videos later. Thank you.